Hey gang, it's Easter weekend 2013. Happy Easter to those of you that celebrate. Today, I'm at home, obviously, because it's the weekend. I've got my TDS 1012 hooked up. And this is I guess really the second video for the building of the logic analyzer. We're trying to use the OK board to make a logic analyzer. Earlier we talked about having the AVR plugged in. Let me go ahead and plug in the board. There we go. The AVR is running at a really low speed to put out just a logic signal and a trigger signal. It's running off the same power. And the very first thing we've done is, unfortunately, this is all in Verilog, but we have taken the OK interface and moved it off into its own module to simplify things. So in there's the OK host, a wire in, a wire out, and a pipe out, and then a wire OR to tie the wire out and the pipe out together and out the door. I can tell you from a little bit of experience here that when you have your count off by 1, I had it 32 down to 17 instead of 33 down to 17 for the pipe out. It's really hard to detect that fault. Verilog's okay with you not assigning everything, and strange things were happening on the pipe out, but I got that figured out and we're working now. The logic analyzer module right now does almost nothing. We instantiate an instance of the OK interface. It's my OK IF. There's a counter, and everything else is the connections out. So the way this is set up is that when a wire in comes in, it is echoed right back out on the wire outs. And the LEDs here on the XEM3005 card will light accordingly. When I tell the user interface to record data, there's a record data button right there. When I tell it to record data, the end pipe's read request enables a counter, and the counter counts on every uptick of the TI clock so that they're synchronized together, and it fires the data out. I did notice an interesting effect. Right now this says if the read request is equal to 1, counter equals count plus 1, otherwise counter equals counter. Originally the else was counter equals 0, and what I've noticed is even though I was only pulling 32 kilobytes, the blocks would stop and it would reset, and so there was a lot of read requests in there because I didn't have a FIFO. So since there's no FIFO in here, it was stopping and starting the counter, and it was resetting it back to 0, and I was chasing that down, trying to understand what was going on until I had a small epiphany there. But a couple of strokes on the woolly booger and a pat on the mouse's head, and we were all good to go. So here we go to show you that this is working, to demonstrate that it's working. I'm sorry, honey, not right now. We're going to load up the logic analyzer, and we're going to bring that back to the front. So no light. Still have this funny light here. I'm still waiting for somebody to tell me why my LEDs are being lit when they are commented out in my UCF file and there's nothing referencing them. So number 4, number 3, number 2, number 1 works just right. 1, 2, 3, and I don't have 4 wired up because I don't intend on using it later. And then I click on the record data, and I will tell it to write it to this file. It's called pipe, and it says it's going to overwrite it, and I'm okay with that. And then I will open up my hex editor and open up that file, and I see it starts at 0001, 0002, and so on, and I only told it to record 32,000 bytes, so here we end at 3E08. I'm sorry, 3E80. And that's all that, so that tells me that my host interface is working, and we are ready to go on to the next steps of the logic analyzer. Bye, gang. Oh, say hi, Adam.
Hi. Who is it?
Say hi, Leah.
Hi. Who is it?
Okay. It's nobody. It's everybody. It's the whole world.